Epta Regulatory News Voices. Conversations on the latest trends and regulations in commercial refrigeration.
Refrigerant gases in commercial refrigeration. This is the main theme, the focus that accompanies us here in this meeting that we are going to start here at Epta Group Home. I'm Marco Ferraro and I'm with Francesco Mastrapasqua, Epta Institutional Affairs Manager. Together we will try to take stock of the current situation linked to the refrigerant gases to find out more about their use, the associated technologies and how we should behave in this regard. Welcome, Francesco, here.
Good morning, Marco. Good morning, everybody.
So let's start with the first question. Why are refrigerant fluids used for cooling in commercial refrigeration?
This is a very interesting question, Marco. Why refrigerants? Refrigerants are a core component of our systems, you know. Refrigerant is a kind of a train that conveys the heat from the heat load from our cabinets, from our cold rooms, from our products, and conveys that through the lines, you know, to be disposed, exhausted in the air, or eventually reused to heat up the store for space heating. And in this case, we are doing an integrated system that has very, very interesting possibilities of efficiency for the whole system, you know. We can do super efficient systems when we are good enough to use the exhaust heat from the refrigeration to heat up the store. So a refrigerant is one of the most important components of our systems. But at the same time, we hear talking about refrigerants, and we got to learn that the refrigerants are not all the same. They have different features, different chemical features, characteristics, thermodynamics, and so on. And since many years now, we have selected the best, the most suitable for refrigeration. But the history of refrigerants tell us that there has been innovation also. We have used refrigerants that were ozone depleting long ago, many years ago. Now these substances are banned. Then we replaced these refrigerants, the industry, replaced these refrigerants with others which we discovered having a global warming effect. Okay. And that we've been using since many years and up to a few years ago. And later on, these ones are currently replaced in the world of chemicals by other substances that have lower global warming potential, but promise other environmental issues like PFAS, for instance. They are, most of them, nearly the totality of them, they are PFAS or degrade into PFAS, with other effects like TFA. But I don't want to make a chemical lesson now. But the history of chemical refrigerants has been made of generations of refrigerants that have been phased out due to their chemical effects.
There's an interesting point to develop together here, Francesco. What's the impact of the refrigerant gases on the environment?
A lot of impacts when they are chemical, no impact when they're natural. We normally use CO2 and propane as natural refrigerants. Natural refrigerant means that these substances are already present in nature, naturally, okay? So using these gases means we do not introduce any chemical with our systems, and everything that we do is using substances that are normally present abundantly in the atmosphere, which therefore have no chemical impact. Long ago, we had the problem of, ozone depletion. We discovered in the 70s, I seem to remember in the 70s, that some substances, some chemicals could have an effect on the ozone layer, making it thinner and thinner. And then later on we discovered that these substances were really making the ozone layer thinner and thinner in the mid-80s, I suppose. So there was the Montreal Protocol, an agreement committing all countries in the world, or nearly all, to stop with these substances, to ban them from their businesses. And we have the result today. We were able to cut 99% of these substances overall worldwide. Yeah. And we see that the ozone layer is restarting to return to its original situation. This is an incredible success story that is a result of cooperation, an international global commitment, a cooperation between science, industry, and market. Science to give us the solution, industry to implement them, market to accept them. And this was an incredible success story that is returning the ambient as it was before we harmed it, before we damage it. Okay. So now we wonder why we can't do the same now with fluorinated gases that are global warmers. The effects of global warming are more and more evident these days. You know, year after year, we see more and more frequent and extreme weather events that tell us that we are really into an emergency, a climate emergency. So time now to take a lead on that. And at least in refrigeration, we are ready to abandon F-gases because we operate since many years, not only Epta, but several other companies, are introducing in the market new technologies which are more and more efficient. We do a lot of research and development and innovation in this field on natural refrigerants that are today have achieved a level of efficiency and sustainability which is unrivaled in the history, I would say, the best ones. So I think that there can be a commitment. We are ready, at least our sector is ready to make a commitment and try as much as possible to phase down the use of F-gases and then in the end stop with F-gases. We are one of the markets that is mature and ready to do so. Other markets, of course, are also in the trajectory, they are in the path of abandoning F-gases, but of course they have been lower to move, or they are a little bit in a more early stage of technology, but they are also investing a lot. I mean, air conditioning, heat pumps, medical devices, fire extinguishing systems, all sectors using F-gases are today moving to natural alternatives. Just because we realize of the impacts of chemicals.
So Francesco, the right question now is how to choose the right refrigerant.
This is a good question, I would say. The recipe, the choice of the best refrigerant, it's a matter of responsibility. We have to responsibly choose the right refrigerant for each application. But I would say one thing's for sure, we want to use more and more, we want to use only natural refrigerants more and more. So choosing the right refrigerant, well, first of all, it's a matter of cost of the equipment. So we have been able during the years to make systems using natural refrigerants, CO2 and propane, more and more convenient, more and more cheap, and that have an overall cost of purchasing and use that has become, I would say, better than the systems that we used to do long ago with natural refrigerants, and the cost is one of the most important parts of the choice, you know. Second, we have to be responsible also in respecting the regulations. We have regulations that are selecting refrigerants according to their environmental impact, according to their global impact, warming impact, and therefore the general acceptance. And also, I would say, the future regulations, which refrigerants will they allow, will they support and encourage, which refrigerants they will little by little ban. Sustainability is also referred to that. Using refrigerants that have no, let's say, dead time, no dead date, deadline given by environmental regulations. At the same time, for us, it's important, and I would say the third pillar is the complexity of the systems. To be sustainable, a system must also be simple. Simple because it's not only designing and installing, but every technician must be in a position to service and maintain the equipment easily, you know, that so that in every corner of the world, a normal technician can manage the technology that we are giving them. And otherwise this becomes a very strong barrier. And we want to eliminate the barriers worldwide to the use of natural refrigerants. So simplicity is key.
Francesco, which refrigerants are mostly used today?
Today, I would say the majority of the market chooses natural refrigerants. Because we understood that, first of all, they are cheap refrigerants, because I like chemicals that are having increases in price, I would say daily, and just because they are limited by the F-gas regulation, so they are increasing in price. And I will also see that sooner or later, in a very few years, in 2-3 years, we will see also problems of availability in the market of some traditional refrigerants that we've been using since until a few years ago. Okay. So the cost is extremely important. And it starts to be in the heart of the people that choosing natural refrigerants is a gift for the environment. And that really matters in the choice of our clients.
So, as a consequence of these sentences of us, what are the most common technologies adopted for food products?
Well, I would say that in the area of small surfaces, small stores and supermarkets, we are using a mix of CO2 and propane. Propane we use to do plug-in cabinets, monoblock units for cold rooms, semi-plug-in systems, I mean water loop systems. So generally speaking, products that are called self-contained. So they have the whole refrigeration circuit inside the appliance itself. They're very easy to connect and start because you just need to give electricity and you can operate immediately. No need of waiting times for installation and so on, and optimizations. This is all done in the factory by the company, by the manufacturer. And we use CO2, of course, which has very, very important and interesting features of performance and efficiency. Whereas I would say in the medium and large store surfaces, that's the scenario where we use mostly CO2 centralized systems with power rack cabinets, remote cabinets, cold rooms, and the whole system is a distributed system called centralized because the power pack is producing the cold, and the cabinets and the cold rooms and other things are using the cold, which is distributed in the store. That's why we call it centralized. And this is the typical solution of medium-large supermarkets.
What if I suggest you this sentence, less space, more technology, concerning the supermarket, for example? What can you comment about it?
Less space, more technology. This is interesting. I never thought about this before. But it's interesting because it tells us, and it's a reality, in the situation of small stores, convenience stores, superettes, typically located in the center of cities, of towns, and so on, there are special typical issues to manage and special needs there. For instance, there can be a problem to install equipment outside, and because it's generating noise or heat, so it could be that it's not accepted by the neighborhood, you know. At the same time, having a small surface, which is typical of these stores, makes a need of displaying sufficiently the products with, of course, large vitrines, large spaces, but at the same time with very compact equipment. Mm-hmm. And there is probably no space for a technical room, so you can't have a power pack or a condensing unit there if you don't want to install anything outside or you don't have a dedicated space for that. And in this case, the solutions are multiple. We have a large catalog of plug-in cabinets, large catalog of integral cabinets, which differ because integral cabinets are cabinets designed to be big, to be for supermarkets, and normally not available as plug-in, but they have the whole refrigeration. We are able to fit all the refrigeration which is necessary to operate within this kind of cabinets, which ensure anyway a very large visibility to the products. At the same time, this type of technologies, let's say, generate some heat inside the store, although it's less and less because we are using more and more closed cabinets, so the cooling demand is lower, and therefore also exhaust heat is very little. But at the same time, we could use this little amount of heat for helping the efficiency of the heat pump, of the heating system of the store, if we go for water loop systems, where the exhaust heat from the cabinets is collected into a water loop and can be entirely, every calorie can be entirely reused for heating up the store, making a very super efficient store, which is also helping not only the retailer to, let's say, have the perfect climate on the store and super efficient heat pumps, of course, but it's helping a lot with the energy bill, which is something our customers like a lot.
So Francesco, I would like to thank you to have translated all these elements in this speech, and I would like to thank all of the audience following us till this moment, and I wish to find you here for further conversation. Thank you again, Francesco.
Thank you, Marco. Thank you all.
Bye-bye.
Bye-bye.